So our next speaker is Dexian Tang, and he's the co-founder and chief technology officer at Causal Foundry. He has a strong background in AI and machine learning, especially in the kind of global healthcare industry and space. And I've had the pleasure to hear Dexian on a previous visit about some of the wonderful kind of AI and data workflows that they are implementing and working on around the world. So I'm personally very excited to kind of hear an update on some of those, and I think you guys will be in for a treat as well. So thanks.
Let me just test this out. All right. Okay. Good morning, everyone. Thank you for the intro. And my name is Dexian Tang, and my talk is going to be shifted a little bit from large language model. I'll be more talking about adaptive interventions. So the title is Adaptive Behavior AI, Reinforcement Learning to Enhance Healthcare Services. So just a little bit about Causal Foundry. We are incorporated in the US, but the team is based in Barcelona. Okay. Right, so this is the outline of my talk. At the beginning, I will just talk a bit about some of the key partners that we're working with. And then I will go a little bit deeper into about the technology we're building, which is called the Foundry Platform. This is the AI machine learning platform. And then lastly, I will talk about specific use case that we have about adaptive intervention with SwiperX. This is a e-commerce pharmacy distributor that's in Indonesia. Yes. Okay, so the vision of the company is that we want to use AI and machine learning to improve healthcare for all by mostly using adaptive intervention. So that's kind of like the cornerstone of our technology. And how we do that is that we have an AI platform that we try to integrate into existing digital tools. And then the key is that we want to ingest a well-structured and very standardized data set, because like anyone work with machine learning, algorithm is only half the story. Majority is like how good the data is. So we ingest those data, we process them, we train model with them, and in turn we use the data from this model and process to do adaptive interventions. So we do not focus on diagnostic. We mostly focus on behavior nudging. Those are some of the key partners we have across the globe. We work with partners both in private and public sectors, and notably our government organization from Rwanda, Kenya, and India. So now I will talk about two partners we have. The first one is called Mother to Mother. This is an organization from South Africa that they employs women or mother living with HIV as frontline healthcare workers. So we work together with them to build an application from ground up that help those healthcare workers to manage their patients. And we're building a lot of machine learning feature into it. For example, you use algorithm to optimize the route when the frontline healthcare worker is trying to do patient visit. And also, we use large language model to help summarize some of the assessment results or patient history so that it helps easier for the workers to digest. Second one is with EdChemist. This is a e-pharmacy network in Ghana. Pharmacists are quite important because in many of the low and middle income country, for many communities, they're like the first line of the access to healthcare system for many communities. And we also work together with them to build applications so the patients are able to directly fill their prescription with the pharmacy, and the pharmacy is able to use this application to manage the inventories. So we build in some demand forecasting to make sure the essential items are always on stock. And also, since this is the patient-facing application, we can use the contextual information from the personalized information of a patient to send them out those nudges about regarding public health policies, such as the vaccination campaign and so on and so forth. So those applications I'm talking about, they are deeply connected with the Causal Foundry platform. So we have the contextual information that we can send out those adaptive interventions. All right. So now I will talk a bit about how we build out the platform. Well, there's two pieces to it. You have SDK that's quite opinionated in terms of how data should come in. So we do not work like individual with different project to say, okay, what are your data looks like, and then we create a specialized pipeline just for you. No, we have a set of data schema that we have already created for different types of events that we want to track for different types of purposes of machine learning we want to do. So once the SDK are integrated into those digital tools, again, it's just like glorified logger that you have different types of schemas, right? That you have to adhere to certain data qualities. So it should be straightforward. Once we have those data, we ingest them, we process them, we train different types of model with them, and on the platform, you should be able to visualize them, administrate them, and then create intervention with the result of those things. And eventually, the nudges are coming back to the end users, to the SDK, so having an impact on them. We also have some large language model integration. So on the SDK, we have a large language model-based chatbot interface, so that any existing digital tools will be able to leverage this interface to explore the data. So a side note on large language model, I think personally for me, it's a great tool to generate data from scratch, right? You can ask to write anything you want. Second, it's also a fantastic user interface to explore data in any existing digital tools. Yeah, this is just like RAG, right? So those are like the two functionalities that when I see building large language model products, like those are the two categories. And also moving forward, we are thinking to have even intervention directly within the chatbot. When users talking with the chatbot based on large language model, because we have the contextual information of those users, we are able to respond to their messages a little bit more, more personalized ways, because it's not just like standardized the result you get from OpenAI APIs. Okay, so there are 4 types of families of algorithm we have in the platform. The first ones are time to event prediction. Simply put, this is just predicting what is likely to happen to whom, at what time, with what probabilities. So this is a very, very broad problem statement. You can model in many, many things with it. But this is incredibly powerful because then you are able to use this sort of prediction to create segmentation of cohort of user and then try to targeting like the population that you want to have some sort of a behavioral nudging, right? Recommendation system, I think most people are familiar with it. It's very incredible. It's very, very useful to help people discover new content. You can, help users discover something that in the system that they are not aware of, but it's very pertinent to them. Adaptive intervention. This is the cornerstone of what we're doing. I will talk a little bit more in depth in the next slide. Resource allocation. Okay, so now for resource allocation is pretty much just like prioritization. So you already know something works well for everyone, but there's an inherent budget cost or limitation comes with it, right? So an example could be in a call center, you need to call patients to follow up, talking about their adherence, but you have too many patients and you don't have enough operator. In this context, who should you decide to call makes the best use of your resources. Okay, now this I'm going to focus more on the adaptive intervention. We use contextual bandit algorithm as the key part of the adaptive intervention. So what does that mean, adaptive intervention? You know about A/B testing, you know about randomized trial. Compare with those approaches where users are, once they are assigned to a certain group, they keep receiving the same thing. But at the center of adaptive intervention is that there's a reinforcement learning model at the center of it. And it's interacting with these 3 variables we're talking about. First is the context information of an individual participant. It can be their engagement level, can be the region, role, experiences, what have you. Essentially just a piece of data that we're using to describe the state of that user's at that moment. And then the model also, there's action. This is just a literature term for like group, control treatment group, or the nudges that are associated with that group. So what are the actions you want to take against this individual user? And then there's a reward that they'll have chose for the model to sort of optimize towards. Either maximizing or minimizing, polarity doesn't really matter. So what happens is the model at any moment when it's about to make a decision, okay, what are the nudges I should give to a certain user? It will look at the contextual information of the user. It will try to predict a reward distribution for a certain action. So since there's like multiple actions, then eventually we use Thompson sampling to pick out the reward that has the action that yields the highest reward. So now model has made the decision. Okay, for this person, this time I'm gonna give these types of nudges. And that decision is done. Once the user has been exposed to that nudge, and then we will also track the response regarding the reward, how the user is actually reacting to this, right? So next time, when the model is about to make a decision again, it will use that previous information to update its own weights and biases. So in a way, it's sort of like, and this cycle repeats. The model will keep going and then, learn every time about the preference of an individual user and they eventually try to achieve this sort of a global max of a certain reward. And I talked about the contextual bandit and then this is a restless arm bandit. This is the kind of algorithm that we use for resource limited situations. That is, okay, You already find out from the previous intervention, this sort of approach really works, but every time there's a budget constraint comes with it. Now you have 100 participants, but every time you can only afford to give out like 10 units of budget, you can only assign like 10 people. Like who do you choose? The way we do this is that for every single participant, you have to create a Markov decision process, which is just like a graph. Then in this graph, you have many different types of nodes, and those nodes are like the states. You can design those graphs. It's essentially just like a simplified modeling version to describe the user, right? Those nodes can be like users. They're high engagement. They have a high engagement level, median, low, or high spending profile, median, low, that sort of thing. And then between each one of those nodes in the graph, there's a transition property. Transition probabilities. And then we can use the historical data to generate this graph with transition probabilities. So essentially, this is just a simplified model version of individual user, how you define them. At each time, it's not a state machine, right? User can be at the T1, it's at this state, at the T2, maybe it has some probability to go to the next state. And now what the model does is that, okay, now you created those graphs to describe the states our individual users are in. And then model looks at contextual information of each user, and then just like go through a for loop. Okay, I have 100 people, but I can only take 10. And then it will just model, right? Every time if I give to this user, how much reward I get. For this user, how much reward I get. And then essentially it just try to find out the 10 people that satisfy the budget constraint, and also at the same time yields a global maximum reward. And then now that's how it picked out those 10 people that satisfies the boundary condition we want. And now you might be wondering, okay, if we're just leaving this to model, for sure there's going to be biases. Maybe the model is just optimizing with some mathematic formulas. In the end, they're always just going to give the reward to this same 10 people because it always yields a maximum reward. And equitable restless band is an approach to sort of combat that biases. So this is an external constraint that we have that is before you even start the intervention, you set it out. Okay, I'm going to split my user into different groups. It can be by their gender, ethnicity, religion, age, location, what have you. So in that case, the model will try to be fair, like when you try to allocate resources, not just like, try to achieve this global gain by choosing individual person, but try to be fair when you try to allocate resources among different groups. I digress a bit to talk about sensory model. This is related to time to event prediction. So essentially, again, I'm trying to predicting what is likely to happen to whom at what time with what probability. On the left side, you can see those are survival curves. Those are real curves from a e-learning application for midwives. So on the left side, you can see the y-axis are just like engagement level. At the beginning, like everyone's quite engaged. But as time goes on, the model sort of predict like some user will like become more disengaged more quickly than the other, So like the blue ones are a little bit more flattened, so they're a little bit more loyal. But for some people, there also tends to, for the white and yellow, they tend to drop off like more quickly. So this is like a modeling profile of the user's engagement level for users in the application. And this is very incredible information that gives you necessary information for you to make decisions about, okay, when should I try to re-engage with this user? So the reason I'm talking about that is that, as I talked about earlier, adaptive intervention is about model taking into consideration of the contextual information of individual user and then make personalized decisions about them. Contexts are really important. Until so far, we only have like deterministic statistics about, we use deterministic statistic as a context, which means it's simply just the result of SQL query that run against some observed logs we have. So those are pretty, deterministic. But by enriching the contextual information with predictive modeling, like you can include like predict the result to enrich their context. This can also make the model to make a more better informed decision. So this is ongoing research we're doing with Professor Susan Murphy's team in Harvard and also in collaboration with Cornell. And just a extension on that. So until so far, we have a bandit model. It takes in contextual information of a single user. It takes in a certain action, and it tries to predict the distribution for certain reward. That reward is the thing that you want to maximize or minimize. But we're also trying to extend that. So then the model can predict like not just like one reward, but try to predict like for multiple reward. And then eventually we're trying to combine the reward distribution of multiple reward into just one. So hopefully we can also jointly improve the bandit's performance. All right, so all the tech talk out of the way. This is the specific use case that we have done with SwiperX. Just to jog your memory, this is a e-commerce pharmacy distributor. Basically, pharmacists buy their stocks from them, and then they also have some like sort of a social LinkedIn component built into it. So it's kind of like a social network plus marketplace with pharmacy in Indonesia. They're quite big. The intervention we did with them, the purpose is to try to increase the variety of the basket size. So the end goal is that so they have more stocks or variety of stocks on their shelf so they can better serve the community. And then the way we do that is that we send out a combination between recommendation system plus adaptive intervention with a bandit. So what we did is that we send out this thing called item pair recommendation. So we examine the purchase profile of pharmacists because we realized, okay, most people, like there are a lot of those pairs that when people buy A, they also tend to buy B together. There are a lot of those pairs. So what we have done is that we're sending out those nudges once a week to lower AT spenders. Like, okay, hey, you recently like bought this, but then normally you don't buy this. How about this? Like we're just sending out like, see if they take that approach, right? And we have observed like a consistent evidence of significant uplift in the expenditure. So we published 2 papers about it. The QR code here, feel free to have a look. And if you cannot get it, talk to me after the talk. This is a t-test for one of the experimentations. So the thick line are the accumulative difference between the average spending of a user in treatment group minus user in control group. So across the time span of 2 months, you can see there's a consistent uplift between the difference of a user, how much user spending in treatment group compared to user spending in control group. And as we know, we are sending them the things that they don't normally buy. So it's logical to think like their basket variety also increased. So is there like a shelf stock in their shop. And at the beginning, the shadowed areas are confidence intervals. And at the beginning, we are quite confident about it, but later it's become less confident. But however, the thick lines are pretty convincing. We also did a restless bandit experimentation with them. So if you remember, this is about constrained resource allocation, which is, okay, it's about, we're sending them discount because we cannot afford to send it to everyone. So we only select a certain amount of people that has reached certain threshold of spending. So this is a restless bandit intervention we did with them as well. This is the table that summarize the result we have. So the first 4 experimentations are item pair recommendation. Those are the things that, like, hey, you buy this, but how about this? Those are contextual bandit interventions. So we observed like there's the impact here simply means user in treatment group spend on average 13%, 16%, 13%, 25% more than user in control group. So we have those double-digit impact. And then the last one is about restless bandit. And this experimentation is still ongoing, and we only observe like 3% improvement. But however, we do observe like 20% increase in terms of engagement. So that was also quite interesting for us and the folks at the SwiperX. Just the last note, we're also working with the Rwanda Social Security Board, RSSB. They have a huge data set with detailed information about claims and insured members. And they're currently moving to a new financing model for their primary healthcare system to improve efficiency and the quality. And we are quite excited and also motivated to be partnering with them to provide data analysis services as well as helping build an AI-driven system together with them. All right. And one last note is that we are it's a great team. We're publishing papers on top journals conferences, and we feel very privileged to be able to work in this sector to make an impact, and we're hiring. Thank you very much.
Fantastic. Thank you so much. We have time for a couple questions.
Yeah, thanks for the great talk. I was wondering how you work with customers to choose the right time horizon for the contextual bandits to optimize that value function rather than the rewards directly.
Sorry, you mean the time? Can you repeat the question again?
So how to choose the discount factors
Ah.
for the future rewards,
I see, I
depending
see.
on what the priorities of the customer are.
Yes, in that case, it's more like an iterative process because at the very beginning, one of the things about intervention or experimentation is that most of the time you don't really know for sure like what will work. So in a way, it's like our data science team and also work together with the partners, their stakeholders. At the beginning, we'll try maybe go a little bit more conservative, and then sometimes even as the intervention goes on, but that's one of the great thing about the adaptive intervention is that we can like even tweak it while it's still going on. So it's quite iterative. We don't really have, let's say, a formula to decide beforehand, okay, this works, and then we'll stick to it. Normally, we'll also tweak it.
Perfect. Thank you.
Amanda, we have a question right here.
Thank you so much for a great talk. I'm just curious, since all your like data are living on your platform through your SDK, I'm wondering how is it more beneficial to use like that platform rather than sort of more of a traditional tech company's approach, which is like micro A/B testings,
If I understand correctly, as you mentioned, it's a comparison between adaptive intervention and A/B testing.
Or like talking about figuring out interventions either through your platform or through sort of like A/B testing, which is what you usually see, right, on these recommendations.
Yes. Yeah, that's completely legit. So our target is, okay, in terms of tech, I don't think what we're doing is like so revolutionary that nobody else is doing. I'm sure in big tech, they all do this internally, right? But then what the key factor is who are we serving currently? Our partners, mostly they have zero tech background. Like it's in ways like we're not exactly providing like self-service SaaS. We are sort of providing a SaaS combined together with sort of a data science consultancy and working with a partner because they don't really have the technical capability to set up like all the things we have. Of course, we have the SDK. Of course, we collect that data. If you want to pipe that into some other platform and do the things, you can do that for sure, right? But they probably need to hire a team of people to manage that thing.
Sorry, so let me clarify. I meant that you could also have an SDK for A/B testing as well. So why is this special to use reinforcement learning versus just kind of doing A/B testing?
Oh yeah, A/B testing is okay. I think depends on the use case. Again, A/B testing, you have this thing that you have to lock up your control and treatment, and then for a certain period of time, and afterwards you do statistical analysis. But the adaptive intervention is that it's more personalized. You are able to, if there's an optimum nudge that the model detects early on, it's able to converge more quickly. So normally, we have some sort of those group portion in terms of a graph. Like you can see at the beginning, the model just like randomly distribute. Okay, if I have 4 arms, I want to test it out, 25%, right, each group. But as the time goes on, the model will try to like explore a bit. So at the end, if you have a certain arm that works, that thing will be like 70% of the users actually getting that. But there are people that's still going to be benefiting from something else. So in a way, with the adaptive intervention, you are able to, if the hypothesis or if something that really works, the benefit is that you are able to converge that more quickly. And then, and in the process might have some financial benefit because you don't want to lose potential customers or that sort of thing.
Great. Maybe one more question for Dexian, and then we're going to transition to the next part.
Okay, thank you for the insightful presentation. So the first question would be on the slide where you showed the countries where you work. Yeah, I think Nigeria, one of the country, their color was in blue, while others were a different shade of color. Can you explain maybe the difference in maybe operations in between? No, the next one? Yeah. Yes, please. So what's the difference in maybe the deployment across the the two different shades of colors? Yeah, then please, I didn't really get the use case in Nigeria. I may have missed it. I'm interested. Thank you.
First question, that's a great question. Yeah. I don't know.
Okay.
To be honest,
okay.
I just don't know.
Okay.
Sorry, what's the second one?
The second would be the use case in Nigeria, please. And I would like to know which organization you partner with in Nigeria.
So the previous map is because
Oh, sorry, this is Enrique. This is the Chief Strategy Officer in Causal Foundry. So I think some of the details he might know better.
Yeah, so the first question about the different coloring in the map of mothers to mothers, I don't have the exact detail of that, but it's the difference on how they operate in those countries. So these are the countries where mothers to mothers are operating currently. And again, there are some differences in DRC and Nigeria, how they are partnering with the government as opposed to the other countries. And that's why they had different color, and we're just leveraging their map. And then the question about who we partner with in Nigeria, which was the second question. We have Checkit there, Field, also working in Nigeria. Those are the two main ones. But happy to discuss after the talk.
Great, thank you. Well, let's thank the speakers one more time. And we have a bit of time actually until coffee break. We had 3 speakers. I'm sorry. Oh, there is. Okay. Just one second, Amanda. So if folks want to leave right now, feel free. However, the speakers have agreed to answer more questions given we have kind of that time and opportunity. So if you have burning questions for any of the speakers, this would be a time to ask, or you can try to go to coffee early. One more question. Yeah, perfect.
So I actually have a question for Kathy. So a great talk, and I think the sort of the kind of the hierarchy of important items for essential AI is I think is great, but I'm wondering, can we comment on how that aligns to sort of the business motivations and models, right? Because the fact of the matter is all these technology and tools are being driven by now big companies who owns the data, and obviously the current restriction that we have has to do a lot with, I think, the IP. I think the previous talker also talks about. So I'm wondering, in order to kind of achieve that utopia of essential AI, like how do you have any thoughts on how that could how we would need to modify maybe perhaps the business model, or perhaps it's the policy aspect? How do we actually get to that sort of on the more practical terms? And maybe there's no good answer, but I thought it's.
Yeah, it's a really interesting question, because in some sense it's like thinking about, well, what will this space look like 1 year from now? I don't know, 6 months from now, 2 years from now. And I think where I had been putting my thought energy towards was actually like, how do we get people in this room excited about this sort of problem, which is an entirely different one than what you're talking about, right? Which is, how do we also make sure that the immense amount of resources, right, and money, and all these huge driving forces that are sort of outside of this room, how can we make sure or think about the directions that those are going to make sure they'll be aligned with some of the hopes and dreams and opportunity that we see now, right, in terms of, and I think from my perspective, pushing towards the open source models is an important next step. The prototypes that I had built relied on the open AI models, in large part out of just a forcing function of convenience. But I think it'll be incredibly important to look at how, not only how well do the open source models perform, but also what opportunities do they provide in terms of adding additional layers of like interrogation in terms of how well this sort of thing is working. But where the realm of open source, like what the environment and system of open source models will look like a couple years from now, like that's, I think, where your question really plays a key role in terms of, what are the solutions and forcing functions that will allow those companies to keep operating in that way. So a really important question that has a lot of implications beyond just that list, right? And just this application. But yeah, thank you.
Okay, we're going to go to another in-person question, and then we'll transition to the question in the chat. Thanks.
Yes, my question is to the Causal Foundry team, and great talk, and just to see how much work is going on in the continent. I wanted to find out more around the data access. I think one of the things we're seeing in Africa that hinders a lot of AI is access to quality data, access to those very sentiment discussions around data. I mean, you're using data on the pharmacy, mother to mother, data from the Rwanda NSSF. I mean, that is really sensitive data. How are you going around that? And also in the context where we are still struggling with issues around data sovereignty and data governance, how are you going around that? And then the second is around the IP. For most of these products and the apps that you're developing, what is the IP for most of this? And then third is the capacity and the knowledge translation in the countries where you're doing this work. Is there any plans for that, or is it more to this and then keep going and not helping the people on the ground?
All right, so I can take a first step, and maybe on the first question around data, you can take that one. But there's issues around data sovereignty, and all the data we have is data from our partners, and if they are taking data from the customers, we just use the same agreement they have with their customers. We're just a processor for our partners on that data. It's not ours. It has happened that a partner has asked us to delete some data because for whatever reason they couldn't. They requested that, and we obviously did that because it's not our data. It's just again, we're having it in the platform for their use. There are things around your question around training or how knowledge transfer to the partner. There's our focus is work with partners that don't have the capacity of doing these things themselves, right? Meta wouldn't be our client, but partners that want to use the same technologies that all these big tech companies are using. So we have a variety of situations in which some partners might have some data science capacity, so not ML capacity to do, to put all these things that the platform has already in place, but they do have some capacity to be able to analyze data and so on and so forth. So in that case, we just help them kind of use the platform and ensure that they can become kind of a good, strong user of the portal. In some other cases, we have a more kind of a heavy role because they don't have that capacity, and it's a little bit of a one by one cases kind of how we do that. There's your first question about the data, how data.
Yes.
Yeah.
Some note regarding the data privacy. So if we're building the application for the user, for the partner, eventually they own that thing. So we're just the developer for them. And of course, on that application, we will, if they want the database in their country, we do that. So in the end, they're the custodian of the customer data. And regarding the data that transfer to the platform, we do not collect the personal identifiable information. So the link between our machine learning capability and the data that's sitting in that database is more just by some sort of ID. So even our side, we know, okay, that's the ID, but we don't really know the names or like more sensitive information. So we try to stay away from the personal identifiable information in the Causal Foundry machine learning platform.
And the IP, yeah. So our platform is, it's our product and it's protected by that IP. The SDK, which is the piece that is used, the libraries and everything that are used on the application of our partners, that's something we develop, but the code is open so they can look at kind of everything that's going on and ensure that they understand the data that they're sending to our platform and so on. So that's the setting.
Perfect. So now I will read the question from the chat. It's from Jeanette Dawa. If I pronounced that wrong, apologies. So Jessica, thanks for a really informative session. What are your thoughts about the use of these models and/or chat boxes in the case of street slang, which could be a combination of several languages, or a modification of more formal languages in urban settings? Is there a consideration for street slang in developing chat boxes to make them more relatable to urban youth? Given that street slang is constantly evolving, how can these models stay accurate?
Yeah, thank you. That's a really good point that there's colloquialisms and slang that are used in common speak, and ensuring that we include this into chat bots for like the demo we built for people with HIV. There isn't an easier answer, unfortunately, than updating your model regularly to include slang, particularly for sexually transmitted diseases. I don't know of another way than explicitly telling your model, updates in slang. What's really great, though, about using large language models, and we've seen this, is that they're really good at code switching. So if you have speech that has multiple languages in it, which is how people talk, then they're really good at picking up this nuance. And they're actually better at doing this than translation models explicitly built to do translation only. So yeah, thank you for your question. It is a really important consideration when we build out chatbots.
Thank you. All right. So we're 2 minutes to the hour. Please join me in expressing gratitude to the speakers for sticking around and answering more questions. What a great session.